Hi, I'm Tom Beebekauser with Wetland Restoration and Training. Today we're going to be looking at how to build small wetlands and forested areas. And these wetlands are going to be designed to help frogs, toads, and salamanders. We're located in Northern California in the mountains, and I'm surrounded by these beautiful redwood trees and Douglas fir trees. The area has been logged a number of times over the years, so there's all sorts of small logging roads and skid trails. Well, we're going to be building these wetlands from log landings, and these are basically parking lots that were used when they cut the timber. Well, let's get started.
Small wetlands in the forest are uncommon and they're beautiful features on the landscape. The open water in small wetlands is very important to animals and plants. Small wetlands that contain open water provide breeding habitat for frogs, toads, and salamanders. These animals use the wetlands for breeding and spend most of their lives in the forest. The black bear also uses wetlands in the forest. This black bear is bathing and getting some relief from biting insects by taking a dunk in a small wetland. I'm sure the bear is enjoying this pond. This video is recorded by Wayne McCrory in British Columbia, Canada. Wetlands that are in sunlit locations within the forest are very important to the successful reproduction of frogs, toads, and salamanders. The warmer water in these small wetlands that are exposed to sunlight for part of the day will speed the hatching of eggs and the development of larvae. It can be difficult to find places to build wetlands in the forest because of the dense trees, the steep slopes, and the lack of vehicle access roads. I'm going to tell the story of how Gabrielle and Dan built 4 vernal pond wetlands on the 440 acres of land that they own in the mountains of Northern California. Their property is in the coastal mountain range of California. The land is forested with large redwood, Douglas fir, and tan oak trees. The average annual precipitation is 45 inches, which is enough to fill a constructed wetland that has a small watershed. Their property has been logged on a periodic basis since the 1850s. Redwood trees have sprouted from the stumps of old redwood trees that were cut many years ago. There's an extensive network of roads on the property, and these were built to facilitate the cutting and the removal of trees. Gabrielle and Dan have worked to control erosion that was occurring on these roads. Log landings were built along the roads that served as work sites for timber harvest. Logs that are cut from trees in the forest are moved onto these landings where they are loaded onto trucks. Sites where log landings have been constructed can be good places to build wetlands at a reasonable cost. This is because log landings have been cleared of trees and stumps, they've been made to be level, and they have vehicle access. Log landings are like parking lots. They're made by cutting into mountainsides to create flat benches. Soil is dug out of the side of the mountain, pushed downhill, and compacted to form a level surface for logging operations. Because log landings are constructed using heavy equipment that moves large quantities of soil, there is rarely a concern that archaeological sites, existing wetlands, or rare species will be disturbed by building the wetland. Gabrielle and Dan walk the roads on their property to identify places where wetlands could be built that would provide habitat for amphibians, including the foothill yellow-legged frog. They identified log landings that were not needed for storing supplies or for parking heavy equipment like this one. Here are some indications that a wetland like this one may be built on a log landing without the use of an aquatic safe liner. Ditches are present that were dug to drain water from the landing and from the access road. Ruts and mud are present that were made by rubber-tired vehicles. Scattered rushes or sedges are present. An adjacent cut bank where soil was removed to make the log landing contains soil that is high in clay. I suggested that we select log landings where there would be no ephemeral stream or ditch flowing into the wetland that we wanted to build. This is important because erosion and drainage can quickly fill a wetland with soil. Another concern in building a wetland in a ditch or a stream is that the excavation itself will cause a head cut to form, and this erosion will soon fill a wetland.
And Dan have found a place where they'd like to build a wetland, and this is on a log landing on their property in Northern California. And we're going to watch as they mark the perimeter of the wetland that they'd like to build.
Alrighty.
So
We should start with leaving enough room for our road here.
the road will come round through here.
Nice round turn there, so probably put the downhill edge about there.
Okay.
And over to this side.
Over under the trees here.
Yeah, in here.
Oh, that looks good.
And
Okay.
can go to the far side.
Okay.
And this could probably go, yeah, clear in there.
Yep. And this will be a nice round shape that the excavator can
We'll make
dig
it
out
easy
easily.
Yeah.
Oh, tansy ragwort.
Oh dear. Get rid of those.
Yeah.
And then probably here.
Up here at the base of this
This
skid,
little
skid
alluvium
trail that
pile,
we call the skid trail that we call the ski jump, the ATV.
ATV
road.
slide, huh?
Okay, and then in between each,
Yeah.
make it a nice rounded shape. Okay.
And for a few more.
Yeah. Yeah.
And
It's pretty rounded, but I guess we can make it irregular with our large
With-
woody debris later with our decoration.
with our decorations, yeah.
Yeah. What do you think here?
I like it.
Okay.
Yep. And let's get
And
one more.
Okay, one
up
more
here.
up there. All right. There we go. What do you think? Can Excalibur, our excavator, do this?
Yes. Yeah,
Good.
here, I think Excalibur will like this
We'll
size.
enjoy this size. Good.
Dan and Gabriel used a laser level and a dual-faced grade rod to mark the perimeter of the wetland they wanted to build. The outer edge of the wetland they planned on building was marked using wire flags. The area they marked had an elevation change of less than 2 feet from the upper to the lower edge. Each wetland was marked in a natural, irregular shape so there would be no straight lines along the edge. Dan pushes a 4-foot-long tile probe into the ground to see if there is at least 4 foot of soil in the log landing that we can use to build a wetland. This can be difficult to do in a log landing where the soil has been compacted by large trucks with rubber tires. Dan uses a soil auger to dig a hole in the center of the wetland that they want to build. They take soil samples and use the ribbon test to determine the clay content of the soil and also to check for the presence of groundwater. Dan used the excavator to dig this deep test hole near the center of the first wetland we planned to build. This test hole showed us there was a thick layer of clay below the surface, with a few living roots from the neighboring trees, but no groundwater. 1/2 inch of rain fell after he dug the hole, and this partially filled the hole with water. We completed the design and layout for the first wetland in less than 2 hours. This was done in significantly less time and at a fraction of the cost that would have been charged by an engineering company. Gabriel works to remove non-native plants by hand from within and surrounding the area prior to construction of the wetland.
We just decided to expand the edge of the pond a little bit, and it's, I don't know, 15 feet more perimeter. And there's a few little plants that I want to save, and that's what we're doing. So I'm weeding out the invasive plants and digging up the little sedges that we can just tuck back into the ground tomorrow, and they'll be just fine. A little sedge and a little Douglas iris. Tuck them away in a little damp bucket. One little sedge. Yeah, so that's enough roots and these beautiful little seed heads. This will speed up the revegetation of our pond edge. And you know, this little area, there'll be maybe 30 plants, and that'll make a difference.
Dan operated the Hitachi ZX40U mini excavator to build each wetland. The excavator has 40 horsepower and weighs 9,678 pounds. The machine has a 2-foot wide digging bucket with teeth. Here's how the site appeared before construction, where we built the first wetland. Desirable plants had been removed and saved in buckets for replanting. Small trees that were growing on the log landing were removed and burned. The puddles of water are from a recent heavy rain. Construction of the first wetland began by using the excavator to remove vegetation and topsoil from within the area that was marked for building the wetland. Dan uses the blade on the excavator to remove plants, roots, and topsoil. The organic material is saved in piles outside of the area where the wetland is being built, and we're going to later spread this in and around the finished wetland. Gabrielle replaces the wire flags that were removed by the excavator when it was removing the topsoil. This is done so Dan can see where to dig the core trench for the groundwater dam. It is important to be on site replacing these wire flags as needed so the heavy equipment operator will build the wetland in the location and the shape you designed. The next step involves digging a core trench around the lower 2/3 perimeter of the wetland that we're building. The pink wire flags show the location of the core trench to be dug. Soil that is high in clay and clean of organics is piled inside of the wetland being built and will be placed back in the core trench, where it will be compacted in layers to form a groundwater dam. Soil that is low in clay is placed outside of the wetland being built and will not be returned to the core trench to build the groundwater dam. The excavator digs deep into the ground to make sure the bottom of the core trench is based on a thick layer of clay that is below the tree roots. I look closely to see if the excavator is digging through the roots and into any layer of sand. I ask Dan to dig deeper if I see roots or sand in the bottom of the core trench. It is of great importance to dig a core trench and to build a groundwater dam. The groundwater dam will prevent tree roots and subsurface permeable layers of soil from draining the wetland. The core trench is dug in sections, with each section being filled with soil that is high in clay and compacted in layers by using the bucket and the tracks of the excavator. The bucket on the excavator is used to compact the clay soil that's placed in the bottom of the core trench. The topsoil, sand, and roots that are removed from digging the core trench are placed outside of the wetland being built, and they're not returned to the core trench. The clay texture soil that's used to fill the core trench is obtained from the trench being dug and is from the center of the wetland being built. Notice how Dan tips the machine to place as much weight as possible on the bucket to compact each layer of soil. Here Dan digs through a patch of organic soil, roots, and sand in the core trench. The permeable soil is removed from the core trench and is placed outside of the wetland being built. He continues digging deeper until he finds clay soil under the permeable soil. You can see the permeable vein of roots and soil that we cut through with the core trench. The excavator places clay texture soil in the core trench and compacts the clay in layers using the bucket on the machine. Dan compacts the upper layers of clay in the core trench by using the right track on the excavator. Notice how he places the machine on an angle and stretches out the boom to place more weight over the track to obtain even greater compaction. He travels back and forth 3 or more times to compact the soil. The core trench is filled with clay and compacted to an elevation that is equal or higher than that of the undisturbed ground along the lower edge of the wetland we're building. Filling and compacting soil in the core trench takes time, and it must not be rushed if you want the wetland to hold water. The excavator is used to remove soil from the center of the wetland that's being built to fill low places in the groundwater dam. The groundwater dam will help ensure that the wetland holds water as planned. An above-ground dam is now built over the groundwater dam. The above-ground dam is built because there was only a small area available to spread the soil removed from digging the wetland basin. The soil needed to build the dam is obtained from the center of the wetland being built. The dam is built in layers from 6 to 8 inches thick, with the excavator compacting each layer by traveling over it 3 or more times. The width of the top of the dam is made to be the same as the width of the heavy equipment that's being used to build the wetland. The dam is built so that it is 6 inches higher than the elevation of the spillway that will also be built. Clay soil that was removed from the wetland basin is used to build gradual slopes along the inside of the dam. The excavator builds the inside slopes and layers, with each layer of soil being compacted by traveling over it 3 or more times. Dan uses the excavator to shape and compact the clay in the dam and in the wetland basin by traveling over the soil 3 or more times in one direction. Dan turns the excavator in a different direction and travels back and forth 3 or more times in the wetland basin to further compact the soil. The combination of digging the core trench and building a groundwater dam and then compacting the clay in the basin will all help to ensure that this wetland holds water as planned. The excavator now shapes a gradual slope along the backside of the dam. Some of the topsoil that was saved at the start of construction is used to build the backside of the dam. Topsoil is used because we do not want to remove more soil from the wetland basin, which would have made the inside slope steeper and the water deeper. Digging the basin deeper could change the hydro period in the wetland so that it contains water all year, and this would not meet our objectives. We can use topsoil to build the backside of the dam because this is part of the dam that is not needed to hold water. The laser level and the dual-sided grade rod are used to measure elevations along the top of the dam. Low places that need to be raised are marked using wire flags. Here the excavator is building up a low place in the dam. Low places are built up with soil and compacted in layers to make the top of the dam level. Water will flow over the dam in these low places and can wash out the dam unless the entire length of the dam is built to be higher than the elevation at the entrance to the spillway. The location for the spillway is selected so that water will flow away from the dam and downhill over a gradual slope in a sheet-like pattern. The spillway is made at one end of the dam so that water does not flow down the road along the other side of the dam. I'm going to take an
elevation reading at the entrance to the spillway. It is a 6.1. I can see that on the back of the rod. Now I'd like to mark the width of the spillway so Dan knows how wide to build it. So I'm going to come over here. We're thinking it should be about this wide. That's a little bit high. It's beeping fast. So we're going to come downhill. There we have a solid tone. So at the base of the rod is a 6.1. So the base of this flag is the same elevation as the base of that flag. I'm going to see if I can move that and put in another flag over there.
That would be good.
Let me see if I can get you another 6.1 over here. So I set it at 6.1. Ooh, we're really close. Okay, right here, the base of this rod is the 6.1. So what we're looking at here is the base of each of these flags is the same elevation. That's where water will flow around the dam and spread out. So what we'd like to see here is a wide spillway or pathway that's level. It comes out fairly flat and then slowly slopes downhill, and that water can't find a narrow channel, and that way we won't have the erosion.
Dan uses the blade on the excavator to create a path for the spillway. The elevation of the entrance to the spillway is the same as the base of the wire flags. The dam was built so that it would be at least 6 inches higher than the entrance of the spillway. It makes the spillway level in cross-section, and so it will follow a gradual slope downhill. What Dan is doing is called back dragging. The spillway is made to be 12 feet wide. Roots are removed so the soil may be shaped and compacted. It is of critical importance that a spillway be constructed to provide a pathway for water to flow out of the wetland and not cause erosion. Here you can see how Dan is back dragging, compacting, and widening the spillway. He's building the spillway so that water will spread out in a sheet-like pattern, following a gradual slope away from the dam and not causing erosion. It takes time to build a spillway, and one must take elevations often to make sure the spillway is built level in cross-section and flows over a gradual slope.
All right, we know that the entrance of the spillway is level and it's wide, even in cross-section. We're going to take a step back, about 3 feet back, and I'll take elevations at a cross-section that's just slightly downhill from the entrance. So we'll start at one edge of the spillway, which has been around here on your track mark. All right.
Yep.
We'll take a reading. Okay, it's a 6.4. So we've gone downhill 3/10. So this is a 6.4. Now what I'm going to do is go straight across to the other edge of the spillway and take a reading. And it's a 6.4. So what that shows me is that this cross section is level and the water coming out of the spillway is going to spread out. So I'm going to take another step back and I'll take a reading here. This is a 6.6. So we've come downhill a couple tenths. Now I'm going to try to go at right angles across. And it looks like we may have gone uphill, but we'll find out. Yes. So I'm going uphill 1 inch, which is really close, 1/10. That is really close. Now, what we can do with this is we can use the rake. You have a McLeod here, and this fine tuning of the spillway can be done with a rake. However, are you going to be placing sod over this?
Yes, that's the plan. We'll take
Well, then-
sod over there.
Then we're very close for putting sod on because the sod will not be perfectly level. So what I'll do here is that I'm going to hand you this, and let me have the McLeod. I'll give you these.
Okay.
And what I will do is just a little bit of raking here, where it looks like it could be just a little bit high. And then take an elevation reading here, please. Okay, you stand straight behind it. There you go. About a 6.55, which is
it's
pretty
about
close.
a tenth higher than-
So I'll take it down a little bit more. All right. I think that'll be close enough. Can make this from you. 6.6.
6.6 in the
Okay.
spot there.
So let's jump down here and see what happens. Is this a ditch or not? You want to go right here? Okay. So hold it perfectly straight. Bring it up. What'd you get? Round it off.
6.8.
Yeah, it's closer to a 6.9. Okay, let's go straight across.
Yeah, closer to 6.8.
6.8, okay. Let's see what we get right here. And it doesn't have to be exact because we're not stretching the tape measure.
6.8.
Looks like we have an excellent excavator operator
Oh, thank
who
you.
has a very good eye.
Oh, thank you.
So what we're looking at here is that the spillway is sloping downhill gradually, but it's also level and cross-section. So if you take a slice out of it, the water will spread out evenly. So we're in really good shape here.
Okay.
Really a nice job on this spillway.
Great.
Dan begins placing the topsoil that was saved in the new wetland. The topsoil is not spread evenly, nor is it compacted. Dan avoids driving in the wetland basin as the tracks of the machine would compact the topsoil. The excavator continues spreading topsoil over the compacted clay soil in the finished wetland basin. Branches and broken roots are left mixed in with the topsoil. The topsoil is placed to be rough and loose with pits and mounds that will increase the plant diversity. The excavator is used to place large woody debris in the wetland. The logs are placed so they will be in the water of the new wetland. The wood is positioned so that animals can hide under the logs or perch on top of the logs. The logs are not anchored as there will be no stream current that can move them from where they are placed in the wetland. Trees, we often call large woody debris, are placed in the wetland that had fallen over near the wetland. Dan had used the excavator to break the logs so there would be no visible chainsaw cuts that look unnatural. Additional topsoil and organic material are placed around the logs that were set in the wetland. The uneven nature of the topsoil that's placed in the wetland will increase both plant and animal diversity. Dan finishes spreading the topsoil while at the same time grading a road around the lower edge of the wetland. The road will allow for driving past the wetland without damaging the wetland or its plants. To protect the steeper sections of the spillway from erosion, Dan used the excavator to harvest and transplant the sod of native plants that were growing on the log landing near the access road. Dan uses the bucket on the excavator to scoop up a section of sod and then immediately moves the sod to where it will be planted in the spillway. We find that the sod will crumble and fall apart if it's set down and picked up a second time before it's transplanted. We place the sod far enough downhill where the plants would not form a dam across the spillway. Here's how the spillway appears as it's being planted with sod of native grasses and wildflowers. I use sod to armor steep sections of spillways when rock is not available. The plants that were saved by Gabrielle before construction are replanted in and around the new wetland. Gabrielle positions the sod by hand to make sure the roots are covered with soil. At the same time, Dan is watering the sod by using a hose, pump, and 275-gallon tank that he mounted on a small trailer. Gabrielle waters the plants within and around the wetland so they're more likely to survive. They plan to water the plants on a regular basis as Northern California receives very little rainfall during the summer and fall. Here's how the completed wetland appears a few days after construction. We expect the wetland to fill with water when the rain returns in the winter. We position the wetland on the log landing in a way that it would not block a road used to access the property. The wetland was built in only 2 days' time and at low cost, without the high expense and delays associated with involving an engineering company. We celebrated the construction of the new wetland by enjoying an ice cream float in the woods.
Gabrielle and Dan, I am so impressed with the wetland that you built. This is your land, and you've taken quite a step by adding a wetland to your property. What do you think of your new wetland?
Oh, I think it's gorgeous. I can't wait to see it full of water and see who hides in under all the logs and in the nooks and crannies and birds we might get.
And salamanders and frogs. And thank you so much, Tom, for coming and
to help us
and
do
encourage
this.
us. Yeah.
What can you say to other landowners about building a wetland?
It's easy and fun.
Yeah. Yep. It's easier than you might think.
The second vernal pond wetland we built was in a shallow basin at the intersection of 2 logging roads. The wetland was placed to help close 2 skid trails to motor vehicle traffic. The perimeter of the designed wetland was marked using pink-colored wire flags. The site has a 2-foot change in elevation from upper to lower edge. Pink wire flags mark the perimeter of the wetland to be built. Topsoil and plants are removed from the surface of the planned wetland by using the bucket on the excavator. This organic material is piled on higher ground uphill of the wetland being built. We will later spread this organic material in and around the finished wetland. After the topsoil has been removed, we dig a deep hole in the middle of the wetland we're building. The hole shows us the depth of the tree roots that will need to be removed, and if there's a thick layer of clay beneath the surface where a groundwater dam can be built. A core trench for the groundwater dam is dug along the lower 2/3 perimeter of the wetland being built. The excavator digs the core trench by cutting through tree roots down into a thick layer of clay. The wetland would only hold water for a couple of days out of the year if we did not build a groundwater dam. The soil and tree roots removed from digging the core trench are placed outside of the wetland being built. This soil will be used to fill an entrenched roadbed after the wetland is finished. The area is so small that Dan can keep the excavator in the center as he reaches the perimeter to dig the core trench for the groundwater dam. The wetland is being built so that it will be deepest in the center and not have an above-ground dam. Clay texture soil is being removed from the center of the wetland being built, and it's placed in the core trench that was dug along the outside perimeter of the wetland area. This soil will be shaped and compacted to form a groundwater dam that will keep water in the wetland. Dan uses the bucket on the excavator to compact the clay soil he placed in the core trench. The loose soil is compacted in layers to form a thick wedge we call a groundwater dam. It's okay if some fine roots are mixed in with the soil, as these are not connected to living trees. Dan uses the weight of the excavator on its tracks to compact the soil he placed in the core trench to form a groundwater dam. The clay he is compacting in the core trench and in the wetland basin forms a large bowl that will maintain water in the wetland and reduce losses of water from the large trees surrounding the site. Dan begins placing the topsoil that is mixed with vegetation over the compacted soil in the wetland basin. The arrow marks the location of the spillway for the wetland. The spillway was located to flow over undisturbed ground along the low edge of the wetland we built. The bucket on the excavator is used to spread a thick layer of topsoil in and around the wetland basin. The topsoil is spread loosely over the compacted clay so that plants will grow and frogs and toads can burrow into the mud to escape predators. Large woody debris is placed by the excavator in the finished wetland basin. Dan will also loosen the topsoil that's compacted by the tracks of the excavator. The soil removed from building the wetland is used to fill the entrenched road. Dan uses the rough and loosen technique to loosen the soil in the compacted road, and at the same time he spreads the soil that was removed from building the wetland over the loosened roadbed. Gabrielle and Dan invited neighbors and community members to see how small wetlands can be built in the forest. These wetland workshop participants helped us place additional large and fine woody debris in and around the wetland. Frogs and salamanders can be expected to attach their eggs to the branches in the water and will be able to hide from predators. Dan waters the plants and soil in the new wetland. The water will not only help the plants to survive and grow, but it should help germinate the many seeds that are present in the topsoil that was spread in and around the wetland. We dug a deep test hole in the center of an area where we wanted to build a third wetland. The deep test hole showed us there was a thick layer of clay texture soil on the site, and we could build a groundwater dam to get the wetland to hold water. Notice how black-colored soil is located below the brown-colored soil. This shows us that topsoil was buried when the site was filled and leveled to create a log landing. I test the soil texture at different depths and find that clay is present in all of the layers. This means that we can dig a core trench that cuts through the tree roots and build a groundwater dam to get the wetland to hold water. Dan starts construction by removing and saving the topsoil from the third wetland we're building. Dan begins digging a core trench that will go around the lower 2/3 perimeter of the wetland we're building. The core trench is being dug deep enough to cut through the tree roots that are present underground. The clay he's removing is placed inside of the wetland that we're building. This clay will be mixed and placed back in the core trench to form a groundwater dam. We removed some large diameter tree roots when digging the core trench. The wetland would not hold water if we left these tree roots in place. I'm surprised by the number of agency professionals, ranchers, and engineers that tell me it's not necessary to dig a core trench and a groundwater dam when building a wetland. When they say this, I know they have very little experience building ponds or wetlands. The groundwater dam is built in sections. Here, clay soil removed from digging the core trench is being placed back in the core trench where it will be leveled and compacted in layers to build the groundwater dam. The process of building a groundwater dam takes time and must not be rushed if you want the wetland to hold water. Dan uses the bucket of the excavator to compact a layer of clay that he placed in the bottom of the core trench. He places the entire weight of the machine on the bucket and then curls the bucket back and forth to compact the soil in the bottom of the core trench. I set the laser level on high ground away from the construction site so we can monitor elevations in the dam as it's being built and determine the location and the elevation of the spillway. The clay soil used to build the dam is obtained from the center of the wetland we're building. This clay soil is spread in layers and compacted using the tracks of the excavator. The dam is built in layers from 6 to 8 inches thick, with each layer being compacted by running over it 3 or more times with the excavator. The elevation of the top of the dam is set to be at least 6 inches higher than the elevation of the spillway. The elevation of the spillway is usually set to be 1/2 the change in elevation from the upper to the lower edge of the wetland that's being built. Here the excavator is compacting soil for building the groundwater dam and the above-ground dam. The above-ground dam is being built to prevent water from flowing out of the wetland and down the road. Dan continues to add layers of soil and compacts each layer by traveling over it with the excavator 3 times or more to build the dam. The pink wire flags mark the entrance to the spillway for the wetland. Gabriel uses the dual-sided grade rod with a laser receiver to measure the elevation of the spillway for the wetland that we're building. The spillway was located so water would flow around the dam in a sheet-like pattern, not causing erosion or damage to the road.
The dam has been constructed, and I'm going to take some elevations and find out if it's level. I'm going to start by taking an elevation at the entrance to the spillway. 10.7 entrance to the spillway. Now I'm going to go up on the dam, and I'm following the crest or the very top of the dam. So this is a 10.25. So that means that we are roughly half a foot higher than the spillway. Lower number means higher ground. 10.2, we're a half a foot higher than the spillway. 10.1, we're about 6/10 higher than the spillway. And here in the corner, this is typically where it's low. But not here, I have a 10.0. That's good, because it may settle here where there's a corner. Curving around. 10.0, which is good. And a little bit higher here. We're going uphill, so it's really not even part of the dam. So here we're about 7/10 high, which is fine. So the dam is at the elevation that we want, if not slightly higher. That means as you run over it, you won't be lowering it, which is really good. We are ready to shape the inside slope and the back slope by using topsoil, and that will give it gradual slopes and help it blend in and make it look natural.
Here's how the wetland appears after the groundwater dam, the above-ground dam, and the spillway have been constructed. The next step is to spread topsoil in and around the wetland and to use this topsoil to create gradual slopes on the inside and the backside of the dam. Here the topsoil is being used to place a gradual slope on the backside of the dam. This gradual slope will help the dam appear like a natural ridge on the landscape. Topsoil is also being spread on top of the dam so it will grow plants. The excavator is now spreading topsoil within the wetland basin. The topsoil is placed so that it is rough and loose with many mounds. Heavy equipment tracks left by the excavator in the topsoil are loosened by using the bucket on the excavator. However, the compacted clay soil in the dam and in the wetland basin are not loosened. The final depth of the wetland is measured by using the laser level and the dual-sided grade rod. At the same time, the entrance to the spillway is raked by hand so it's level. This is done so water will flow out of the wetland in a sheet-like pattern and not cause erosion. Ezekiel does an amazing job adding large woody debris to the finished wetland. The redwood log that he's moving into the wetland will provide hiding cover and perches for many animals that will use the wetland over the years. It's very important to add coarse woody debris to wetlands you build because it could take hundreds of years for trees to naturally grow and eventually fall into the wetland. Dan begins watering the plants and the soil in and around the newly constructed wetland using the pump and portable water tank after Gabriel finished planting. Gabriel collects the duff from redwood trees that will be used to mulch the exposed soil around the new wetlands. She uses a rake to collect a portion of the thick accumulation of needles and small branches around the base of the redwood trees and then places this duff in a container with rope handles that she made by recycling a plastic barrel. Removing the thick layer of duff will also protect the redwood trees from the prescribed burns that they're conducting on their property. Gabrielle spreads the duff for mulch on higher ground around the newly constructed wetland. She's careful not to step on the plants that she recently planted. The duff will help control erosion from heavy rains and will maintain moisture in the soil that will facilitate plant growth. The duff also gives amphibians and vertebrates a place to hide. Here's how the third wetland appeared the day it was completed. There's an abundance of logs and branches that will give amphibians a place to hide. The wetland is expected to fill during the winter and spring when rain returns to Northern California. We call the fourth wetland we built the Buffalo Wallow. This is because the wetland is small and shallow and looks like what a buffalo could have been made by wallowing in the mud. It only took Dan a couple of hours to build the Buffalo Wallow with the excavator. However, because the wetland was so small, he was not able to do a thorough job compacting the thick layer of clay in the basin with the bucket and the tracks of the machine. Fortunately, the dedicated individuals attending the wetland workshop volunteered to help us compact the clay in the basin. By stomping and jumping up and down, they were able to mold the separate chunks of moist clay together. Their efforts formed a thick and impenetrable layer of clay that extended up to the surface of the ground. This wetland would certainly hold water. Here's how the basin of the Buffalo Wallow wetland appeared, that's lined with a thick layer of compacted clay before we added topsoil. Dan spreads the topsoil that was saved in and around the Buffalo Wallow wetland. He places the topsoil in the wetland so it's rough and loose, taking no action to remove sections of the roots or to compact the topsoil. I use a rake to spread the topsoil, working to blend and taper it so it doesn't look like somebody placed a large donut around the wetland. The hand raking allows me to make the spillway even in cross-section so that water will flow out of the wetland in a sheet-like pattern and not cause erosion. I also use the rake to slope the upper edge so that runoff will enter and not flow around the wetland. I add some coarse woody debris to the wetland to provide birds with perches. Gabrielle uses a rake to dig a shallow hole for planting. She then walks over to where the plants were stored and picks up a plant that was saved before the wetland was built. She places the plant in the hole and uses her hands and a rake to place soil around the roots, and then carefully pushes soil into the ground around the roots of the plant to displace large air spaces. The area around the plant is raked, and she's ready to dig a hole for the next plant. Gabrielle and Dan watered the plants and the soil around the new wetland by using the pump and the water tank they had mounted on the trailer. We noticed there was water left over and decided to use this water to fill the new wetland. We placed the end of the hose in a bucket. This was done to spread the flow of water to reduce the chance of erosion. The bucket was removed after the wetland was filled with water. And here's the Buffalo Wallow wetland filled with water. It won't be long before the dragonflies and frogs find their new home. Now let's look at an ephemeral wetland that we built in 2019 on a log landing that's located on the Umpqua National Forest in Oregon. The objective of the project was to convert an old log landing to an ephemeral wetland that would provide habitat for native amphibians as part of a road decommissioning project. We decided to use an aquatic safe liner to build the wetland because the texture of soil in the log landing was low in clay and the soil was mixed with round river rocks. You can see how much rock was in the soil by looking at this photo of a stream channel that we built to replace a ditch on the log landing. A small excavator was used to dig a shallow depression for the wetland. The basin was dug deepest in the middle. The red-colored wire flags mark the perimeter of the wetland being built, while the piece of rebar with an orange ribbon attached marks the center. A skid steer was used to move rock away from the excavator. There was a lot of raking and picking up rocks for us to do in preparing the basin for the installation of the aquatic safe liner. We placed a one-piece, factory-seamed aquatic safe liner that was protected on both sides by thick geotextile fabric in the basin. We anchored and trimmed the corners of the liner and the geotextile. Here's the liner and geotextile before we covered them with soil. The operator used the bucket on the excavator to place 6 to 8 inches of soil mixed with rock over the liner and geotextile and was very careful not to travel on the liner with the machine. The thick layer of soil and rock will protect the aquatic safe liner from being damaged by deer and elk and will provide amphibians with a safe place to burrow into the mud to escape predators. We placed large woody debris in the new wetlands to provide turtles with basking sites and birds with perches. Here the excavator operator places a log near the edge of the new wetland. Salamanders, frogs, small mammals, and vertebrates can live under these logs where they're not in the water. The logs also give the animals a safe place to hide between the trees and the open area around the wetland. The excavator operator then uses the rough and loosen technique to loosen compacted soils around the new wetland to facilitate the retention of precipitation and the growth of plants. The wire flags were left in place to show the operator the buried edge of the aquatic safe liner. These wire flags were removed after the soil was loosened. You're looking at the new ephemeral wetland that took less than 1 day to build using an excavator and an aquatic safe liner. Here's how the wetland appeared in February of 2021, after it had filled with rainwater in the winter and along with some runoff from the road. Here's the wetland in March of 2025. Native frog species are breeding in the wetland that was built from a log landing. Log landings are excellent places to build ephemeral wetlands in the forest. These wetlands that dry in the fall will provide breeding habitat for frogs, toads, salamanders, and many other animals. Ephemeral wetlands can be built on log landings at a low cost. These constructed ephemeral wetlands can last for thousands of years. Isn't it
Amazing how you can build a naturally appearing and functioning wetland in a forested area where the logging has taken place years ago? And this wetland that we've built should be around for hundreds, if not 1,000 years. So if you have forested property where logging's taken place, I encourage you to consider building small wetlands. They can be any size because the benefits of these small wetlands are tremendous. You're going to help a lot of wildlife species, a lot of frogs, toads, and salamanders. Well, this is Tom Beebe-Kauser with Wetland Restoration and Training. And if you like this video, please let me know. And of course, subscribe so you won't miss any future episodes. And I wish you every success building wetlands in the future.